Hey, welcome to the show. Today we're diving deep into one of the most electrifying finds in astrobiology. You know, the discovery at Cheyava Falls on Mars.
Oh, yes. That's the one with the 3.5 billion-year-old rock from Jezero Crater, right?
Exactly. And, it's like a whisper from Mars's ancient past, hinting at microbial life.
Absolutely.
This rock, nicknamed Cheyava Falls, contains a mix of organic matter and minerals that on Earth we'd pretty much shout out as evidence of ancient biology.
Fascinating. So what exactly did they find?
Well, first off, there's a key element, organic carbon being present. Now, organic molecules are the basic blocks of life, even though they might also appear through non-life processes.
Yeah, that's a neat twist.
But then, there's something even more intriguing. The rock exhibits these textures that scientists call poppy seeds and leopard spots. These correspond to two iron-based minerals, vivianite and greigite.
Right. And on Earth, that particular mineral combination is often found where microbial metabolism has occurred, isn't it?
Exactly, it's like, when you see those minerals together in a lake bed, or a riverbed in this case, it's a huge hint that microbes might have been feasting there. They essentially use the organic matter as fuel, and their metabolic processes left behind these distinct chemical traces.
That fingerprint is key. But, wouldn't there be a way to explain these mineral deposits through purely geological means? I mean, couldn't hydrothermal processes, for example, also produce such features?
That's the critical point. There's a healthy dose of scientific skepticism here. The researchers are well aware that nature can sometimes mimic life-related processes. So, yeah, they're not claiming it outright as proof of life. It's, a potential biosignature that needs even more rigorous testing once the sample returns to Earth.
So, it's more about setting up the ultimate experiment, right? Like, the Perseverance rover was the scout, and now the real answers await in Earth's labs.
Exactly. Perseverance isn't just hunting for signs, it's also collecting tiny rock capsules like Sapphire Canyon that will be brought back. Think of it as Mars sending us a sealed message in a bottle that we have to decode with our advanced lab tools.
Yeah, a sealed message waiting to reveal its secrets. And let's not forget the location. Jezero Crater, right? It's basically this ancient lake with a fan-shaped delta that really favors the preservation of organic fossils.
Right. Jezero's geological history is crucial here. Billions of years ago, it was a vibrant lake, fed by tributaries that deposited sediments in a perfect delta formation, making it an optimal environment for life and preserving its evidence in the form of mudstone.
It really is like nature's own archive. Now, what about the instrumentation? Perseverance isn't just any rover.
Exactly. It's loaded with some of the most advanced scientific gear ever sent to another planet. For example, SHERLOC, a mouthful acronym for Scanning Habitable Environments, with Raman and luminescence for organics and chemicals, is a key player here. It's equipped with a UV laser that maps out minerals and organic compounds in meticulous detail.
Right, so it's not just snapping pictures. It's almost like doing chemistry on the fly. And that instrument is what really gave the first hints of, where those poppy seeds and leopard spots were, right?
Precisely. SHERLOC's detailed mapping allowed scientists to pinpoint areas where these unusual textures exist, which in turn led them to drill deeper into that very promising piece of rock. It's like being handed a treasure map and digging at just the right spot.
That's a cool way of putting it. Now, I'm curious about the whole contamination issue. How do we know those organic compounds aren't just from Earth?
Great question. NASA strictly follows planetary protection protocols to prevent Earth contamination. Everything is sterilized to an extreme. Plus, imagine this. The organic signals were found deep within a 3.5 billion-year-old rock. The idea that they could have lurked in there due to modern contamination seems extremely
it's hard to
unlikely.
fake something that old. So ultimately, this finding isn't a definitive "I found aliens" moment. It's more like a highly promising clue that life could have existed, right?
Exactly. It's a clue, a sort of whisper from Mars that life might have taken hold. But because extraordinary claims require extraordinary evidence, the scientific community is, rightly so, cautious. They're looking at multiple lines of evidence here: chemical clues, geological context, and a solid plan for bringing samples back to Earth to apply more precise analytical techniques.
A multi-layered approach. And once the sample gets back, there are even more advanced techniques waiting, like electron microscopes to look for microfossils and isotopic analyses to check for biological signatures.
Exactly. It's like peeling an onion, each layer revealing further detail. Life tends to prefer lighter isotopes, so if we see a significant shift in ratios, that could be pretty compelling evidence for biology.
Right, that detail could be the smoking gun. But I do have to challenge one point. Isn't it kind of risky to interpret these mineral formations as biological without definitively ruling out all abiotic processes?
That's a fair challenge. There's a valid caution here. Life naturally makes you want to see intentional patterns, but geology can trick us with similar outcomes. That's why the scientific community is emphasizing extensive lab tests under simulated Martian conditions. It's a careful dance between skepticism and hope, you know?
Yeah, I see the balance they're trying to strike. So in a way, it's like we're standing at the threshold of a vital discovery. Not quite a firm yes or no on ancient life, but more a promise of something big.
Exactly. It's a pivotal moment. Cheyava Falls isn't a time capsule that immediately shouts life existed, but it's our best target yet that whispers the possibility. And it significantly boosts our confidence that, yes, we're looking in the right place with the right tools.
It really changes the game. It's impressive how much thought goes into selecting the landing site too. Jezero Crater wasn't chosen at random. It's this ancient lake with sediment layers that preserve the history of life.
Absolutely. The crater's aqueous history is a goldmine, literally and figuratively. By studying sedimentary rock, we're not only examining minerals, but reading an ancient, preserved record of environmental conditions, which is where life would have most likely thrived.
Right, it's like reading a diary that's billions of years old. And with Perseverance grabbing these rock cores, it's effectively passing the baton to future missions.
Precisely. It's part of the Grand Mars Sample Return Campaign. The rover collects and caches these critical samples, and then another mission will scoop them up and send them back to Earth for detailed study. It's a long-term strategy that underscores just how important this discovery is.
It shows how every step counts. Now, looking forward, what are the next big questions we need to tackle before we make any definitive declarations about ancient Martian life?
Well, for starters, scientists will replicate the conditions that created those minerals to see if they can occur abiotically. They need to rule out everything from simple chemical reactions to more exotic geological processes like hydrothermal activity. And then there's the microfossil search using electron microscopy on the returned sample. If we see preserved cellular structures,
that seems like the promising
that'd
yet
be
challenging
monumental.
next step. It's basically a process of elimination, proving that life was the only plausible cause for the observed chemical signatures.
Exactly. It's a rigorous, patient process. We're not looking for a snap judgment here. We need a comprehensive case built on multiple independent lines of evidence.
No room for shortcuts when it comes to extraordinary claims. And that's what makes this discovery so pivotal. It shows that our methods for exploring the deep past of Mars are really hitting their mark.
Yes, it's a moment of both scientific excitement and cautious skepticism. Cheyava Falls marks the transition from merely habitable environments to a rock that tells a chemical story with the ingredients, the traces, that hint strongly at biology.
Right. It's a whisper that could eventually turn into a shout. I like that analogy. The whisper that keeps us wondering. So, ultimately, while we haven't found definitive proof yet, this discovery has, in many ways, revolutionized our search for life beyond Earth.
Absolutely. It's about refining our questions and expanding the boundaries of what's possible. And, with the Mars sample return mission, the next few years could bring us answers that reshape our understanding of life in the universe.
It's exciting to think where this could lead. Well, here's to the future. The thrill of discovery and the relentless pursuit of truth in the cosmos.
Cheers to that. Stay tuned, because as we dig deeper into these Martian messages, we're not just exploring another planet. We're exploring the origins of life itself.
Thanks for the chat. It's been a wild ride through time and space, from ancient riverbeds to the labs back on Earth.
Exactly. Until next time, keep your eyes on the stars and your mind open to the mysteries they hold.